Hello students, in today's class we are going to read a very small and interesting topic. It's not a huge topic but it's very much important, and this particular topic plays a huge role in understanding the resistivity, conductivity of various materials. So the topic over here is about mobility. In general English, if we see what is mobility, mobility is all about the motion. Mobility simply defines the motion. So any sort of motion seen is the mobility. Here, what sort of mobility we are talking? We are talking about the motion of the electrons in a conductor, motion of electrons and positive ions in an ionized gas, and motion of the positive and the negative charged ions in an electrolyte. So a metal is basically something in solid state. So here the only free thing which can show the motion are the electrons which are in the orbit. Now just see, this is our metal, or if I say I'll make one atom, okay? So if we are basically having one atom over here, this atom is having a nucleus and electrons in the shell. So in the outermost shell, these electrons are less bound or freely bound. Freely bound. So once we are applying the electric field, these electrons get enough energy to exit out this orbital structure and be free, show the motion. So these are the solids, and this kind of motion is shown in the metals. So in metals, the only thing which shows the mobility are electrons, whereas the ionized gas, just see the bromine iodide or some other gas, if we say like helium or something. So these, when we ionize them, they will become B plus, I minus, or helium plus and some electron. Okay, and if hydrogen is separated, H2O is ionized, it will give us H plus and O minus and so much. Okay, so this is what we call ionization. They are becoming ions. These are known as ions. Ions are something having the positive or the negative sign. The ions are basically the material or the element which have lost or gained an excess electron. Like when it loses, we add a plus sign. When it gains, we add a negative sign. Okay, so these are the ionized gases. Then if we talk about the electrolytes, electrolytes are the solution which have free electrodes or the charged ions. See, if we say FeSO4 is added into some solution, that is an electrolyte. Okay, element added in a solution, element plus solution, and this element is electrically active. This element is electrically active. So this whole thing will make a electrolyte where both the positive and the negative charged ions show the mobility. Now the concept of conductivity. How does the conductivity arises? It is due to the proper motion of electrons. If electrons are traveling from the one end to the another end properly, when we have applied the electric field, they will conduct the charge, and hence the concept of conductivity is successful. So this concept of conductivity is all about the mobility. It arises from the mobile charge carriers. If our charge carriers are mobile, if our charge carriers are showing a perfect motion with the applied voltages across the ends of the conductor is a good it's good in conducting. I'll say a metal or a element, when applied with the electric field, the amount of mobility shown by the charges defines its conductivity. I'll write it up like the words I have said. I'll write here for the better understanding. When electric field is applied across the ends of the material, mobility of electrons in it defines its conductivity. Hope the statement is as clear as a mirror. Now we'll move to the part of mobility. Mobility got a very simple definition. It is the magnitude of drift velocity per unit electric field. How much velocity they have or the electrons have attained for a unit electric field is the mobility. If I am applying 1 electric volt of electric field to the material, the drift shown by the electron as a sum over is known as mobility. I will write my statement once here for the better understanding. When a unit electric field is applied, amount of drift motion shown by electrons gives us mobility. Just copy it down. So for your understanding, I'll erase. So this is what the mobility is. Mobility is given by a Greek symbol known as mu. Mu. It is kind of U with a left longer leg. Okay. U is same as mu, but what is here? We are having a left leg which is long. Okay, mu equals to Vd upon E, and the unit is meter square per volt second. Meter square per volt second. Meter square per volt second. So see over here, meter per second is the SI unit for Vd. For E it is volt per meter. Okay, volt per meter. Meter per square into 1 upon volt plus volt per meter. So it gives us meter per volt second. Here it comes. This is how we are getting the SI unit. Now we know that drift velocities formula is E tau E upon m. This is the charge, relaxation time, electric field, m is the mass. Substituting this equation over here, we will get mu equals to Vd upon E, that is E tau E upon m into E. This E and this E will cancel, which will give us E tau upon m. So mobility in terms of electric charge and relaxation time and the mass is given as mu equals to E tau upon m. And here tau is the average collision time for the electron. We have seen tau is the average collision time. Or what is the next thing we can say for the tau? It is the relaxation time. Tau is relaxation time. So this is our question, this is our formula for the mu. One thing which is quite important over here is 1 meter square per volt second equals to 10 to the power 4 centimeter square per volt second. And mobility is always and always positive because the motion they are showing, whether in the opposite direction or in the forward direction, it will never change the direction of mobility. Mobility is motion, and motion, if something is moving, motion is positive. If something is moving, motion is positive. Take it as motion, don't take it as velocity or a vector quantity. It is an extremely generalized term. Okay, Now see over here how this is being defined. 1 meter square. So 1 meter square per volt second equals to 10 to the power 4 centimeter square volt second. How this is coming? See, 1 meter equals to how many centimeter? 100 centimeter. Then 1 meter square will be 100 centimeter the whole square, which will give us 4 times 0 centimeter square. 4 times 0 is 10 to the power 4 centimeter square. That is how we are getting this particular relation. Okay, hope you understood what is mobility and hope you understand how important for us to understand mobility is. So that's all for today's class. We'll see the limitation of the Ohm's law in the next class or the upcoming one. Okay, till the time, go through these concepts, understand it, and try to learn, grasp and understand the derivation and the relation of all these derivations with each other. Okay, have a good day. Bye bye.